Okay, just for the record purpose, I'll go through whatever has happened. This would also help the students who joined late. So in the yesterday's class, we looked into non-preemptive methods like FIFO, LIFO, shortest job first, and then priority-based scheduling. So now today we will see preemptive-based scheduling. So what happens in preemptive-based scheduling is, say, let us assume that P1 in this problem, P1 is scheduled first. Y and all, we've already solved this issue numerical. So P1 is scheduled. Let us suppose that when P1 is executing at the fifth millisecond, P3 appears. P3, let us assume that it has higher priority than P1. Now, if it was a non-preemptive one, then P3, despite being a high priority task, it will wait for P1 to complete its time frame of 10 milliseconds, and then it will be scheduled. Whereas in preemptive, what happens is, because P3 is higher priority, at the 50 millisecond it has come, immediately P1 will be pulled away from this, from the execution, and P3 will be scheduled. So, and then P1 will go back to the ready queue. So this is roughly about what is priority based or preemptive based scheduling. So every task in the ready queue gets time to execute. So the task which is getting executed is stopped, preempted, stopped temporarily, and another task which has higher priority or lesser remaining time as per the scheduling algorithm from the ready queue, it is taken and it is executed. The task which is preempted by the scheduler is moved to the ready queue. So this process of taking a running process, this task of not task or process, this act of moving a running process into a ready queue is called as preemption. So this preemption could be either time based or priority based. The first now preemptive based scheduling which we will study is shortest job first. It is shortest job first. The name holds good for non-preemptive one, because once the task is scheduled, it will complete the time frame time frame which it requested. That means it will get executed for the time frame which it requested. But in case of preemptive, it doesn't happen, because as soon as a higher priority or as soon as the scheduler decides, because of the algorithm, that some other task in the ready queue has to be executed, the current process which is getting executed is removed from execution, and this new process is put into execution. So now this removed process will have some amount of time that is left for execution. So SJF in preemptive generally is better called as shortest remaining time. So in this problem, again, we are taking the same thing, 10, 5, 7, P1, P2, P3, the frame required. So P1 is scheduled first. P2 is scheduled first because it has the shortest time frame required at the starting. So 5 milliseconds. At the second millisecond, 2 milliseconds. At the 2 millisecond in time, what is happening is P4 comes into the ready queue, and it has only 2 milliseconds time frame for getting executed. So it is the shortest one. That means it has the highest. It has to be scheduled executed. But now P2 is getting executed. 3 milliseconds of execution of P2 is still left. But because this is a preemptive scheduling, what happens is P2 is removed from execution and put into ready queue, and P4 is put into execution. So P4 will take 2 milliseconds, and after that 2 milliseconds, P2 is left out with 3, P3 is still having 7, P1 is having 10 milliseconds, so P2 is rescheduled again. So at the fourth millisecond, P2 has 3 milliseconds left, P3 has 7 milliseconds left, and P1 has 10 milliseconds left. So the shortest remaining time is P2, so P2 is rescheduled. Okay, hope so you people have given the answer in the group. Yes, I have one answer. Okay, yeah, that's good. Yeah, Maheshwari has put, somebody has read it, I think so, right? Okay, Maheshwari, I think, yeah. Maheshwari, I think you can put the direct one, ma, so that everyone can read and then you can delete it. Manikandan, same with you. You can put the image simply like that without the privacy thing. Then you can delete it, because let all others also get to know that the correct answers. Yeah, I will also be showing the correct answers, but still, hope so your answers are right. If not, kindly correct it. So the solution goes like this: waiting time for P2, that is the initially, it is 0 milliseconds for the first shot, and while it is ready for execution, but because P4 comes, it has to wait for P4 with a very short execution time. It has to wait for 2 milliseconds. So total waiting period for P2 is 2 milliseconds. I think this you shouldn't have made a mistake. There is a reason given in the bracket as well. And time for waiting for P4 is 0. Waiting time for P3 is 7 milliseconds. Waiting time for P1 is 14 milliseconds. Waiting time for P3 and P1 is pretty direct. So total waiting period times divided by 4. So 5.75 milliseconds. Turnaround time. So for P2, that is time spent in the ready queue and execution time. Or what you could do is, it is just now P2 will get complete its process at 7th millisecond. So you can tell that the turnaround time is 7 milliseconds. Okay, and P4 complete its execution at 4 minus 2. It started off at 2, so it is 2 milliseconds. So 2 milliseconds, and then for P3 it is 14 milliseconds. P1 it is 24 milliseconds. Okay, this is the total turnaround time divided by 4. So you can see here, I'll go back to, it is 5.75 milliseconds and 11.75 milliseconds. I'll go back to SJF non-preemptive. It was 11 and 18. Look at here, it is just 5.75 and 11.75. So don't you feel so it is quite improved because of preemption? Okay. Okay, the title has to change 1 minute. Yeah, I've updated the title. So it is preemptive scheduling, preemptive AGF scheduling. Okay. So the next scheduling, any doubts you can ask me. If you have any doubts, any clarifications needed for this?
So for P4,
Okay.
for the second, I mean the turnaround time,
Okay.
like I didn't get like how was it 2 milliseconds, then rather 4 milliseconds because that's
If
where I
it
went
had,
wrong.
yeah, that is that is what I was checking. Why is it 4 milliseconds? P4
Because it's
does
the total time no, so like the time it waits plus the time it takes to execute no, so
correct. See, if P4 was ready as soon as P4 completed, say suppose P4 completed at 4th millisecond, and let us suppose it is ready again for execution. Will it have to wait or can it continue? It can continue, no, because
mm,
P3,
it can
because
continue. Yes,
yeah, so it is
it
only
has the
2 minutes.
shortest time.
Yes, yes, yes.
Okay.
Because P2 would be left out only with would be left out with 3 milliseconds still at the 4th millisecond, right?
Yes, sir. Yes, sir.
That is all.
Okay.
Yeah. Okay. Yeah. Moving on. So preemptive, next type of preemptive scheduling is round robin scheduling. So what happens in round robin scheduling is, so you have this process one, process two. And take the example. Look at the example here. You have process one, process two, process three, and process four. So each process is in the ready queue, and each process is executed for a fixed predefined time slot. The execution starts off by picking up first process in the ready queue. So this process gets executed first slot. Okay, when the predefined time slot elapses or when the time frame is over, then context switching happens, and process 2 gets executed. Process 2 gets executed for a stipulated amount of time, and then process context switching happens, and then process 3 happens, and then process 4 happens. So it's about round robin. It is not about who came first or who has the highest priority. Nothing like that. So whichever is ready, it will just take into picture and then it take into the execution, and then it will start execution. It is similar to FCFS. The only difference is that the time slice is preemption based. That means there is a specific time slice. You don't execute a process for the amount of time it requires. You will execute the process for the amount of time which the scheduler decides. So the time slots are predefined. So it is same FCFS only, but with a predefined time slot or a preemption based time slot. Okay, going on. So we will take again the same example, P1, P2, P3, but a little bit of different time period because uh, the algorithm is going on becoming a little bit complex and complex. So 6, 4, and 2. P1 has 6 milliseconds, P2 has 4 milliseconds, and P3 has 2 milliseconds. So enters the queue altogether. So calculate the same thing. Calculate the turnaround time, waiting time and turnaround time for each process, and the average waiting time, average TAT in the round robin algorithm with a time slice of 2 milliseconds. So every process will only get 2 milliseconds. So let us suppose in the order it came. Not let us suppose. Let us take the order it came P1, P2, P3. So first P1 will be executed for 2 milliseconds. That means you will be left over with 4 more milliseconds. P1 will be left over with 4 more milliseconds of execution, and then P2 will be executed for 2 milliseconds. It will be left with 2 more milliseconds of execution, and then p3 will be executed for 2 milliseconds. That's all is the p3 requires. So after p3 the scheduler picks p1 again. So p1 will have what 2 more milliseconds after this, and then it will be p2. So this goes on. So until unless all the process is completed, execution of all the process is completed, this round robin picking up of the tasks will go on. So calculate the average time.
Sir, I had one more doubt.
Yeah, tell me.
So, for example, the very first process, there won't be any waiting time. So, suppose if I'm calling that process after a set of process, would waiting time come into account or not, sir?
No, because it is round robin. Whichever came first will be given a chance, but it won't
No,
be given a
I'm
chance.
asking generally, sir. I'm asking generally in terms of preemptive scheduling itself. So, for
Okay,
example, if I'm calling process A in
okay,
the first slot, and after that I'm doing process B and process C, and again I'm calling process A.
okay.
So for the second time when I'm calling, should I consider the waiting time spent in doing process B and process C, or shouldn't I consider that,
For
sir? That's my doubt.
for what? For
For the
calculation, is
second
it?
time, yes, sir. For the second time when I call process A,
Yes, it is waiting, right?
yes, sir. So it should be considered, right?
Yeah, isn't it?
Okay, sir.
For example, P1 initially it was 0, then it has to wait for 4 milliseconds, then it has to wait for 2 milliseconds, correct?
In this case, sir.
Yeah, in this case, in this
Yes,
example
sir.
case.
Yes, sir. Yes, sir.
Initially, it will be picked up first. Then it has to wait for P2 and P3 to complete. So 4 milliseconds. Each time frame is 2 milliseconds. In the third iteration, because P3 would have completed, it has to wait for one time slice. That is 2 milliseconds. So
2
totally,
milliseconds.
yeah, P1 would have waited for 6 milliseconds in total.
Yes, sir.
Again, keep your answers ready. I'll call out the names. They'll have to share their solutions into the in the WhatsApp group. So there are quite a lot of students leaving once I tell that. Harshit Chopra and Jivita, kindly share your uh, solutions in the WhatsApp group. After we complete the discussion, you can remove the message from the group.
Okay, sir.
Yeah. Make it quick so that we can complete this one and then we can start off interprocess communication tomorrow or next class. We only have 2 weeks. I don't know how much of syllabus we can complete. And there are a lot of special classes for you happening from other courses. So I'm just thinking, I just think, should I burden you people or not? Yeah, we have some solution. 5.33, good. 4 milliseconds, yeah. So you can see there, I am not sure about 4 milliseconds. Average turnaround time, I think it should be more. No, whatever you calculated is Jivita. Yeah, Jivita. Yeah,
So the next process comes after like the P1 again starts to execute at 14 milliseconds, right?
correct. No, but whatever you calculated is total average time. Sorry, it's the average waiting time, not the turnaround time.
To average, yeah.
So you have to redo the whole
Okay.
thing for TAT. That's all.
Okay, sir.
Yeah, yeah. This exercise of putting the snaps onto the group is not to, criticize anybody or check on anybody, so that I'll get to know what is happening. If there are similar mistakes like the things happening, the mistakes done by the students who would be sharing, then everyone will get benefit out of it. So as of now, 3 sharings have happened and no mistakes have been found out. But still, if there is any mistake in further classes, everyone who has got similar mistakes would also get the solution instead of just asking. Harshit?
Yes.
Yeah, share your thing just to check out, okay? Because generally, the by average, all the mistakes would be similar. That's why.
So same thing I have done.
Okay. Don't hesitate to share, okay, from the next time.
Okay, sir. Okay, sir.
That will also push others also to be more organized in an online class, which is damn mandatory. It's more than technical stuff. It is about the discipline which we follow. Uh, Almost a similar discipline as in the class should be followed at home as well.
Yes, sir.
Okay, so that will so yeah, where is the process? Yeah, so something like this you should have done. So as I was discussing with Manikandan, I suppose P1 has 6 milliseconds. P2, first time it has to wait for 2 milliseconds, then it has to wait for 4 milliseconds because it has to wait for the complete cycle. So it has 6 milliseconds of time delay. And then P3 has to wait for 4 milliseconds because it has only 2 milliseconds of time to be executed. So there is no need for it to come back on the second iteration. So the average time would be 5.33. And the turnaround time, the time spent in the ready queue and execution time. Time spent in the ready queue is nothing but 6 milliseconds, P1, and it requires 6 milliseconds for execution, so 12 milliseconds. Time spent in ready queue by P2 is the waiting time, that is 6 again, and it requires 4, so 10 milliseconds. Time spent in ready queue by P3, that is waiting time is 4 milliseconds, and it requires 2 milliseconds, so it is 6 milliseconds, so 9.33. So you can see from yesterday, whatever you can take the same numbers as yesterday and again check for this round robin, and you can comment on, you can tell in the group whether the average waiting time and average turnaround time improves or becomes better or becomes worse. So you can not in the group, okay, you can just have this solved. Tomorrow in the class we can discuss about it. Okay, hope so you got to know the assignment properly. Repeat the round robin scheduling for the problem which we are taking from yesterday. That is, P1 is equal to 10 milliseconds, P2 is equal to 5 if I'm not wrong. Okay, 5 milliseconds, and P3 is equal to 7 milliseconds. Take 10, 5, 7 and take the time slices. First case 2 milliseconds, second case 4 milliseconds, third case 5 milliseconds, and then tell how the waiting time and turnaround time is varying. Hopefully everyone recorded the assignment, noted down the assignment which I've asked you to do. Okay, tomorrow we'll have a discussion on the results which you've got. Okay, moving on. So but I'm sure that your average time and average waiting time and average turnaround time will better because of one thing, preemption, and the other thing is every task is given a same similar time slices. So moving on, priority based scheduling. So we had priority based scheduling in non-preemptive as well. So in preemptive, the only difference is as soon as a higher priority task is ready in the ready queue, the currently executing process will be preempted, will be made to will be removed from the running state to and moved to the queue, the ready queue. Okay, so we'll go back to the same problem and check out the scenario and find out the answer. So there is no need for me to read it again. But initially, see 10, 5, 7 again. So three priority is 1, 3, 2. So 0 being the highest priority and 3 being the lowest priority. That means P1 has the highest priority, P3 has the second priority, and P2 has the third priority. Okay, and we'll assume that P4 with an estimated time completion of 6 milliseconds, highest priority, higher than P1 comes. So what happens? P1 initially P4 isn't there, so P1 is getting executed at the fifth millisecond. P4 enters because P4 has higher priority than P1, so P1 will be preempted. So P1 is still left out with 5 more milliseconds of execution, so it will be waiting. So as of now, as of at the fifth millisecond, so if I write it here, P1 at the fifth millisecond, P1 is left out with 5 more milliseconds of execution. Now P4 will be executed because it has the highest priority and it requires 6 milliseconds of execution. So it completes because this question does not tell us whether there is any other higher priority task which is coming at time limit coming in the time frame 5 to 11. If it comes also, it can't be higher because the highest priority is already given to P4. Okay, at the 11th millisecond, P1 is left out with 5 milliseconds. P2 is left out with 5 milliseconds, and P3 is left out with 7 milliseconds. So which one to schedule, P1 or P2? Both have same similar time left. Can anybody answer? P1 or P2? Yeah,
P1, sir, because of the priority.
yeah, it is not about the time left, it is because of the priority. The priority is not changing. So priority is 1, P4 is completed. So highest priority is completed. So no more its priority will come into the consideration. So the priorities of the process which is in ready queue comes into picture, because once the P4 is completed, it is moved from the ready queue. Okay, it is moved to job queue. So now P1 is the highest priority task. It has 5 milliseconds left, so it will be executed. So the rest of the 5 milliseconds it will complete. At the 16th millisecond, P1 is done. So P2 and P3 has higher priority, so it will execute. It will take 7 milliseconds. At 23rd millisecond, P3 is over, so left out is P2, so the P2 will be complete. P2 will complete. Okay, so this is a scenario which happens. 2 more minutes. Give me the average waiting time and average TAT. And again, for today's class, the thing remains the same. I'll call out 2 names. They'll have to share their results in the WhatsApp group. Lokita and Sandeep. Be quick because we are running out of time. Lokita and Sandeep, kindly make it soon. Okay, they are taking much time. So you can see here, time waiting period for P1 is initially it will be executed, then it has to wait for 5 milliseconds. Sorry, 6 milliseconds. So total it will be 6 milliseconds. P4 is 0 because it will come and it will finish. P3 16 and P2 is 23. It is pretty simple. So it is 6 plus 16 plus 23 by 4. So priority based preemptive is increasing the waiting time, right? And waiting time and average turnaround also is getting increased. Okay, we can come back to this if required, but there is a simple observation. There is something called as aging, starvation in the priority-based scheduling, as we saw in the yesterday's class. This starvation problem can be solved something by using something called as an aging technique. What is this aging technique? If you find a priority a task in job queue from long time, then temporarily improve its, boost its priority, or make its priority zero or the highest. Okay, make its priority highest, such that it will get into execution and complete its task. So now and then, so every that means what, every task which comes to the job queue, sorry, ready queue, should have a timestamp at which it has entered. That is, what is its waiting time? So if its waiting time is going on increasing and increasing and increasing, that means it is starving. So this starvation can be solved by something called as an aging technique, wherein temporarily you increase the priority to the highest, and then get the job done. Okay, so this preemptive priority scheduling gives us a real time behavior, because as soon as there is a IO access or a human interface or something, we can give highest priority to that, and then we can ask the system to respond to it. Okay, so you can make the system more responsive to human inputs despite of whatever internal that is happening, by using such a preemptive priority scheduling. So this was some number of non-preemptive and preemptive scheduling algorithms. So generally there will be some mix and matches of these sort of algorithms which is implemented. There is a little bit more of mathematical analysis that we could do regarding each priority based or each scheduling, preemptive and non-preemptive. Like what would be the saturation, when would deadlock come into picture, all those things. So when the time permits, I will do it. So now tomorrow what we'll do is, after this class, we have two more slides. After this class, tomorrow what we will do, or the next class what we'll start is, we'll start something called as an inter-process communication. Okay. Now what I want you to do is, one thing is the assignment which I gave regarding this issue, this problem. Okay, round robin scheduling. You have to do it for 10, 5, 7 with time slices 2, 4, and 5 milliseconds. And the second one is, you have to read about what are the differences between a process and a task. Okay, what is the definition of process and a task? So two more questions: definitions of process and a task, and what are the differences between process and a task. So these three questions you will have to prepare yourself for the next class. Okay, and then just go through this one. I'll give you 1 to 2 minutes. This is summary of these multitasking and multi-scheduling. Just go through this once. So whatever we have done in the last 2 days or 3 days, for that matter, we can. It has been just summarized. Lokita shared something and she deleted. Would have allowed me to see. It's okay, ma. It's okay. Also, you went through the slide, and if you have any doubts, you can ask me. Meanwhile, scan this code and mark attendance for the day. Any doubts you can also ask me now. And don't share this QR code with anyone else in the group. There are 27, 25 people. If anybody has any doubts, you can just ask me. Meanwhile, you can scan this QR code and mark the attendance for today's class. And please put it in the official group, unofficial group, that there are chances of NSAR also, because you had major part of your semester offline. Can you tell me, just confirm whether attendance marking is possible?
Yes, sir.
Okay, thank you. Okay, if you have nothing else to be discussed, then you can mark attendance and